makers, welcome back to the shed. My name is Chris, and in this video I'm going to show you how to introduce a switch to your circuit. Now if this is your first time in the shed, be sure to check out our earlier videos. For this make, we're going to use a new electronic component called a tactile switch. This is a tactile switch, and tactile means you want to touch it. Do you want to touch it? So here we can see our tactile switch in a circuit, and I want to touch it. I really want to touch it. I touch it. Now, there are lots of different switches that we can use in our circuits. We've already looked at tactile switches, but there are also toggle switches, arcade buttons, and even telegraph switches. And I'm sure that you've seen lots and lots of switches around your schools and houses. Now all of these switches are based around the same technology, and it's called the quick break light switch. Which reminds me! Okay makers, I'm here at the Discovery Museum, and here you can find out loads and loads of stuff about technology. They've got some fantastic installations that tell you all about our industrial heritage. If you haven't been down, what you doing? Come down and see some of this cool stuff. I'm going to show you something upstairs. Come with me. Hi makers, in our last video we spoke about Joseph Swan and how he invented the incandescent light bulb in Gateshead. Now in 1880, Joseph Swan went around the whole of the UK giving lectures on his invention. And in the crowd of one of his lectures was a young man named John Holmes. And John Holmes was so inspired by what Swan was saying that he asked Joseph Swan if he could be his apprentice. Now Joseph Swan said no, but that didn't stop John Holmes becoming an electrical engineer. And what he developed 4 years later was something that we still use today. It was a brand new light switch, because you see, up until that time, the light switches would actually catch fire. And he created a brand new one, and he invented it in Shieldfield in Newcastle. And it was called the quick break light switch. And there's one of those right here. Now we want to switch you onto computing, and we're going to switch to a different location. Come with me! Now, all switches work in the exact same way. But in order to see this, we need to do a Big Stuff Breakdown! So, here I've got the model of an inside of a switch. And inside of all of these switches, there are two strips of metal that are separated. Electrons can't flow between these two pieces of metal, but the switch pushes another strip of metal down to connect the legs together. And when this happens, the legs are connected and the electrons can flow through the switch. So, when the metal pad is up, the switch is off and the light doesn't light up. But when the metal pad is down, it turns the light on because it's connecting the strips of metal together. So a switch has got two states: off when they're not connected, and on when they are connected. Now that we know how switches work, let's put one into a circuit and make stuff together. Now the first thing we're going to do is we're going to put the female end of one of our jumper wires over the 5-volt pin. Then we're going to put the other end into the positive rail of the bus. The next thing we're going to do is we're going to take a resistor, and we're going to attach the resistor to the positive rail there, and we're going to put the other end into A3. Then we're going to take our switch and we're going to bridge it between E3 and the other side of the trench over there. From there we're going to take our LED, we're going to put the long end into J5 and the short end into the negative bus, and we're then going to take our final jumper wire and go from the negative bus to the ground rail. And once we've done that, if we press the button, the LED will light up. Okay makers, in this circuit we're using a tactile switch, but really all a switch is two strips of metal that get touched together. So we can make a switch out of anything. And that's what we're going to do. We're going to use two male-to-male jumper wires and create our own switch. Now I'm going to take this switch out and I'm going to replace it with two wires. So I'm just going to take that out. I'm going to put one wire in E3 like this, and I'm going to put the other wire in F5 like this. Now I don't have a switch in the circuit, but when I press the two wires together, the LED comes on. Now we can take this even further and attach our jumper wires to something else that's metal. Aluminum foil. Check this out. Now I'm going to cut out two squares of tin foil and attach them to my jumper wires so that I can make a different kind of switch, because metal conducts electricity. So I'm going to take a little bit of tape and I'm going to attach my jumper wire to the tin foil. I'm going to do that with both of these. Alright, now because the electrons are now passing into the tin foil, when they touch together, it should make the LED light up. Check it out. By making our own switch, we open up a world of possibilities. Take a look at this. Check out my magic finger switch. Now remember guys, make stuff is not just about electronics. It's about using your understanding to make really cool stuff. Check out this diorama that one of our makers has produced. She's called Ruby, and what she's made is a diorama. But inside of her diorama she's put LEDs, and the LEDs are connected to switches so that when we press this one down, her treasure chest lights up with lots of beautiful rubies, and when we press this button down, the seaweed lights up. Oh my gosh. Thanks for watching this video makers. We've looked at switches, we've looked at how we can add them to circuits, how they work, how the technology behind these switches was developed in Newcastle. We've created our own switches and we've added them to other projects. Until the next time you head to the shed, get out there and make stuff.